Take it away, Ondřej.
Thanks, Ben. So many nice, kind words. I'm not sure it's true. Anyway, I hope I have something to offer, and you can please make me a co-host, Ben.
Sure. 1 minute. Okay, you're all set.
And we're good to go, probably. Can you see the slide?
Mm-hmm.
Good. Yeah, so Ben already mentioned what's the story. It might be a bit critical talk, but we all know about passive acoustic and the vibe behind it, but maybe it's not so pink as we think. Maybe it is, but I rather see the dark side of it, or at least I did. So I hope maybe at the end of talk we can discuss and you can tell me it's not so bad. bit of context. Ben already mentioned during my studies at the University of Groningen, I could conduct my research project abroad. And so I contacted people from the Cornell Lab of Ornithology, and they were happy to say that I can come, or I was happy to hear that I can come. And mostly I work with Connor. I'm not sure if he's here. From the Center of Conservation Bioacoustics, and Connor works with BirdNet, and you probably know about BirdNet as the algorithm to get bird identification from a vast data set. So I got in touch with him with this project, the data set, and the goal was to figure out how we can use this huge data set in another way than how to say it, other way than just occupancy modeling, if we can get something else out of it. Well, here you know this graph probably. I still hear some noises in the back. I'm not sure if it's someone has mic on. And there is a big boom. We all know that about passive acoustics. And we can easily record 24/7 with these small devices, and it will probably get better and better, and we can easily collect terabytes, petabytes of data in a very easy way. And it's happening already. And thanks to BirdNet, we can also analyze this big data, terabytes of data, very easy way, and get millions of detections of the bird species. Right now, I think it's North America and Europe, but it should expand, and there should be more and more species, if that's correct. And the question, or right now, how we're using the data, we're using just small part of the data. We mostly use the species there or not. Well, that's fine, but there is much more. We can know how often the species is calling, when it's calling, the phenology. We can, for instance, I had the dream that we can distinguish sites that have mated males and unmated males based on the number of vocalizations they do. So that was my initial idea. Yeah, we can do that. It should be quite easy to see that unmated males would sing most of the day, where in contrast, mated males would stop singing after dawn chorus. So the idea was to expand this and see what's there and how we can use the data. I had two main questions, basically. First, how we can use this big passive acoustic data to answer other questions than the species absence and presence only. And the second question would be then, if we can use the BirdNet outputs, the raw BirdNet outputs for occupancy modeling or for any kind of occupancy studies. And if not, what are the limitations? Or if yes, what we need to keep in mind to work with this kind of data. Connor provided me with this amazing data set from Sierra Nevada, a long-term passive acoustic monitoring. Many people are involved with from the University of Wisconsin, I think mostly Connor and other people from the lab. I used data just from one season 2021. And that's something now that I'm showing you, that's like a case study. I think we can think about many other monitoring passive acoustic studies that use similar kind of data and might have similar kind of problems. The sites are spread across this vast elevational gradient, latitude, And each side was recorded 35 days with the Swift unit. And there was this morning and evening interval, 7 hours, 4 in the morning, 3 in the afternoon. In addition to this acoustic data, I could extract elevation covariates or sunrise sunset times and many habitat remote sensing data that I thought I will use a lot. I started and then I stopped using it, and I will tell you why maybe and why I'm a bit hesitant to use them. And finally, all those recordings were analyzed by BirdNet, and maybe I should mention how this was done. The BirdNet was, that's quite straightforward. You upload it, you analyze with BirdNet, and you get the outputs. When BirdNet says, maybe for those, if there's someone who doesn't know how the BirdNet works, it splits the recording in 3-second intervals, and then try to recognize the species within those 3-second like chunks of audio. And if the species has very nice audio and it's very clear that that's the species, BirdNet would say, I'm quite confident or almost certain that it's the species. Sometimes it's not the case, and it will be like, I'm not sure, or it's not so, I'm unsure about this. And this unsure or almost certain, these categories are based on a confidence score from 0 to 100, and where 0 is unsure. And this it was trained and it works well, but sometimes it can happen that BirdNet, when it's almost certain, might be actually wrong, or other way around, when he thinks or it thinks that it's not that species, or I'm not sure it's that species, is actually correct, and it could be correct. So what Connor did with other people, that they selected 100 randomly these chunks of audios for each species, and then local expert went through those recordings and said if it's the recognition of the species is correct or incorrect, and then compare it with the confidence score, and then we could draw this like binomial regression and see where is the actual threshold, the accuracy where it's breaking, and we could say that this data or this confidence score of BirdNet, for instance, 70%, everything above is always 99% accurate. So there is like very small chance to have false positive in data set. So the initial goal was to work just with this data set, but indeed we are maybe losing a lot of data, also those like uncertain or most of the time correct, incorrect. So we use also 95% subset and 85% subset. So there is a chance of false positive, but we get much more data, which are probably correct and might be useful to have those. So I hope this was clear. And BirdNet can analyze any species that was trained on in those North America. So for Sierra Nevada, basically all the calls could be analyzed, most of them, but I chose just 6 target species. And I try to compare, I selected these species because they have different social life histories. Some of them are common, some of them are resident, some migratory. I will not talk much about the details, just that there were these 6 species. Maybe this is a better summary. So I end up with having 3 common species in the data set, 3 rather rare species, 3 resident species, migratory, and then 3 that are habitat generalist, we can say, and 3 rather specialist. But there might be some minor adjustments indeed, or it depends also where in the Sierra Nevada you are and so on. But that was quick introduction, and now first of the results, and I will try to have more time to discuss some of them, and hopefully we have time for discussion as well. So occupancy. This part of the results started with this paper maybe, or it's building up on this paper of Connor. What does occupancy mean in passive acoustic surveys? The classical approach in occupancy modeling is when there is a species, we give 1. If we got 1 detection, then the site got 1. If the species is not there, it gets 0. But with the passive acoustic data that are recording for 35 days in this sense, we can record the species basically always. If the species is there just flying over and we record 24/7 or most of the day, it can happen that we got one for the site, even if the species was just flying over the site or was there just passing through just once. And we can then, there's a question, do we want to use this site in our occupancy modeling or in our distribution maps, or we want to exclude it and we want to include just sites that were every day visited by the species, for instance. And we have the data in the passive acoustics, and we need to decide where to make the threshold and what kind of the subset of the data to use. Maybe I can give you a better example. So this is already the data. It's from one site for acorn woodpecker. At x-axis, we see days from start of May and recording till the end of July. And on the y-axis, we see 10 minutes intervals. It's split in two parts. That's the morning, 4 hours in the morning and 3 hours in the evening on top. And where you see blue, there was detection. Where you see darker blue, more detection, slight less, and white is for no detections. So you see on this side, the acorn woodpeckers were vocalizing all the time, basically, except few 10 minutes intervals. But that's not always the case. This is another site, which would be in our models, of course, occupied. But you see the acorn woodpecker was there much less vocal. Probably it wasn't also there so much often. And we got many sites that look like this also. So the acorn woodpecker was there 3 days, 4 times, 4 intervals calling, but the rest of the time was not there. And the question is, are we going to use this site for the occupancy estimates? And if so, how it's going to change our estimates of occupancy? There is a big difference. Here we talk about site that's, I say, highly occupied. The species probably breeds close to the recorder. And this is the site where the species probably just passing through, or it's a feeding area. So to see how the estimates of occupancy are changing for different criteria of occupancy, I decided to use these 2 very similar approaches. First one, I asked how many days from those 35 days the species was detected. So for this example, we had this acorn woodpecker was recorded 3 days, so yeah, 8% of time. And then we could do it in maybe more quantitative way, that we use the 10 minutes intervals. And I ask how many of those intervals the species was calling. So we see that's it's much less, but comparable maybe. And then when I focus just on this criteria of the proportion of days with detection, I can ask how many of those 35 days the species was calling. For instance, if it was calling more than 1 day, that's the first interval. Can you see my arrow here? So in this above 0, so if this site had at least 1 day with recording, then make naive occupancy here. So how many percent of all the sites, the 1,600, were occupied? And we see lines for different species, and we see most of them turn out to be around 90% of naive occupancy. If we consider this criteria, it's just 1 day, minimum 1 day is fine. And that's a lot if you think about it, when we think about the whole Sierra Nevada. And this data are from the 99% subset of data. So we don't think they are like false positive. It should be correct. So the species move a lot around, and the acoustic data from passive recorders will record them indeed. And then we might make some maybe wrong conclusion when we would take just this 1 day detection or not. But this changes, as you see, if we take 25% of days with at least 1 recording per day, which is equivalent of 8 days, I think. then it changes rapidly for some species. Yeah, it drops from 90 to 40 or even less. So this is important to keep in mind. And this is basically the raw distinction of two approaches we can have. We can model sites that the species use for any kind of reason, passing through or feeding there or whatever. And then we get the very high naive occupancy, even higher probably for some occupancy modeling, or we focus just on sites where we know that the species there around the recorder most of the time. So they are probably the most important sites or breeding sites. And then the naive occupancy for an coon woodpecker would be just 15%. Yeah, so same graph, just a bit more context that the upper three lines are for the common species. Most of them have similar trend. And then there are the rare species, and you see how they drop similarly as well. And I mentioned that I had two approaches. The one based on proportion of days. The second one is based on proportion of those 10 minutes intervals, so the more quantitative one. And I was interested in if we can combine them or where they overlap. Maybe that's a word. So for sites that had more than 95% with detection, that's the equivalent of having at least 10% of those 10 minutes intervals occupied. So maybe if we would use just 1 week of recording and 10% of the 10 minutes intervals would be occupied, we already know the species would be there most of the recording season, and that's the highly occupied and important site for the species. Anyway, but here I think it starts to be interesting, and I will spend a bit more time with this graph maybe. So at the x-axis we see it's the same. I'm comparing proportion of recorded days with detection for here a coon woodpecker. Y-axis is naive occupancy, and the three lines indicates different the bird net detection accuracy. So I mentioned before that we use the subsetting, the 99%, 95, 85, basically subsets of possibility having some false positives. And you see how the estimates varies, and it's yeah, if you think that the decision if you use 99 or 95 would change 50% naive occupancy estimate, it's a lot. And when you inform stakeholders or whatever, that's a big difference. And maybe we should discuss a bit more how to approach it together, people that works with this data, because it can create like big differences. But after all, you see that at the end, if we would take 95% of days, they come to the similar estimate. So that's probably the true after all. The sites that are highly occupied, whatever the data we use, 85 or 95, they come to similar results. And then we can look at the rest of the species, and surprisingly we see that the trends are not always the same. If you look at the Pacific flycatcher left bottom and next to it Plumbeo virea, we see that they are quite similar. Those are the rare species. All the different levels of accuracy fall in the same way. But then if we compare the coon woodpecker, for instance, the American robin, we see it's different. And the 99 for 0 is similar, like yeah, among all the confidence intervals. But they are more distinct at the end. So when we would like to pick up just sites or select sites that are very important for American robin, and we want to be sure we don't have any false positive in the data, then we end up with estimate of 5%. But if we use 95, it already jumps 20% up. And if you think that we have 1,600 sites, that's a lot. Okay. let's move on then. So that was the nave occupancy. I maybe one more comment. I decided to use the nave occupancy and not do any modeling because it turned out to be almost the same, especially when you use the passive acoustic data. If the species was there, it was recorded. So there is no uncertainty in the data, basically, if that was clear. And another part of the results was detection and occupancy scenarios, to realize what we can actually record, why we are recording what we are recording, and what are the limitations of it. So first, we need to realize the biggest limitation of recorders, and that's the very limited detection range. What you record, and I could see it in the data, depends on where you place the recorder. And if we place it blindly without not knowing if there is a territory of the targeted species or not, we are running in a risk recording just part of its vocalization or missing it totally, even if it's in the proper habitat. The limiting range is very, very small. So the species might be there, that's the A, or we might be at the border of the territory, and then B, or species might be out of the range. That's clear. And with this data set, I could look at something very interesting, because each site had 2 recorders divided by, in average, 900 meters. And so within the same habitat, we had these 2 recorders, and we can see how what they can record. We can, if we use the occupancy modeling with habitats, we would expect that they record a similar thing or similar species in a similar fashion, but that's not true, as I will show you indeed. And we also need to keep in mind that when they record for 35 days, the chances that the same bird would be recorded at both sites is pretty high. That's different from point counts or any other censuses that use just short time window. So example, this is map, and there are 2 sites that were recorded. I placed the red circles like the hypothetical detection range. And on the right side, we see the results of it with the blue 10 minutes intervals. So you see the blue is mostly occupied most of the time, and just I think in fact it was 600 meters above in the similar habitat, there were much less detections. Makes sense. And now why it was like that? So the first idea is that the same bird or same bear was moving in that area, a territory that mostly overlap with the one at the bottom, and sometimes they went to the territory above. That's one possibility. Or it could be that there was actually another territory of the acorn woodpecker on top that just slightly overlapped with the detection range of the one above. Or there was another bird, the one at the bottom, and that's why the one at the bottom had so many detections, because there were 2, it was recording 2 different birds. And we can think about many other scenarios. And I was interested in to see what are these typical scenarios and why it's happening, and what we can learn from it. Another thing to, or the approach that I chose to do to proceed further was simple idea. We have 10 minutes intervals, or we can choose 5 minutes intervals. And if the sites are 900 meters apart, the chances that the same bird would be detected at both sites within 10 minutes intervals are rather small. So then it's just about plotting and asking how many intervals within the same time had detections. And if there were many 10 minutes intervals at the same time with detections, the chances that they recorded 2 different birds are higher. If there were just few of these overlapping intervals, then it was probably one bird moving in the area. I hope that's clear. And the detection scenarios, or how to look at them, I decided to use standard deviation as a comparison. We can have sites, that's the left column, let's say, which both have almost no detections. from some reason. Either they are not interesting for the birds, they just passing through, whatever. And they could be similar. Both have minimum of detections, and the SD would be smaller. Or they both can have, like, let's say, middle. The birds would come there to feed probably a lot, or they would be at the edge of a breeding territory. Again, if they are same, the standard deviation would be small. It can be also small for sites that are both highly occupied. So is basically the question was, is it possible that there are two sites 800 meters apart that could be both like very important for the species and occupied by two different pairs or groups? It seems it's possible. I will mention it. And lastly, we can have sites when one is almost no occupation, the bird just rarely comes to the place, and one that's highly occupied. Then the SD would be high. And
Ondřej, just to make sure it's clear to me and perhaps for other people, the SD that you're mentioning is the total number of detections per site, or the SD of detections per day, pairwise site?
Yeah, that was the number of intervals from the total one. Yeah, 10 minutes intervals. And so if you had 10 and 10 and they were similar, then the SD would be low. If one would be 1,000 of intervals with detection, 100, then the SD would be big. Did I answer? Yeah. Thanks for the jump in if you have something is unclear. And the results, I will start slowly with. Now we look at just the acorn woodpecker and just the sites that have very small SD. So they are very similar. And at the x-axis we see that's the proportion of all recorded intervals. So 100, that means most of the time the bird was there. 0, it was not there. And at y-axis, that's the number of overlapping intervals within the two pair sites. So higher you go, the higher chances you recorded two birds because they had many overlapping intervals, and the chances that the same bird would run, fly there and back is smaller. Whereas if you go down, it's possible it was one bird. And what we see, of course, what's happening, there are sites that are for sure recorded two different birds. And what's maybe interesting, that even within the close range, we can have two sites that recorded two different pairs of birds most of the time. There's a lot of calls. But there are also sites where we cannot be sure if it was one bird or not. So maybe take-home message here, the 1,000 meter distance from two recorders when recording for a long period of time does not need to be enough to be sure that we did not record the same bird twice. At the same time, it's possible to record two different birds. And if I add the other standard deviation, so the sites that were more different in a way what they recorded, we see it's possible. There are sites when there are many detections and you move 800 meters in the same habitat, mostly same habitat, and suddenly there is no acorn woodpecker or just a few detections. And here maybe it comes to the loop to the start. If we would focus just on the sites that are very important for breeding, we might drop sites in the same habitat just because, I don't know, because of the placement of the recorder, because the acorn woodpeckers were flying somewhere else, but it's the same habitat, and I would be very cautious about using it, maybe. So how it looked on the ground? We had many sites where it was probably just one bird passing or touching both territories, not visiting them a lot. We had two territories where it was sure there were two different birds touching it from maybe north, from south. And we had many sites where there was acorn woodpecker for sure overlapping one recorder, and a few meters away there was another family of acorn woodpecker in the same habitat. So everything is possible basically. And the same analysis or analysis comparison for other species, American robin, that's maybe interesting in a way. We see a lot of green down there, and it might come to the ecology of the bird, how they move in the area, or what's the size of their territory, how they sing, how they are detected. It seems overall that they had many sites with few detections. both scenarios were possible, that they were detected at both recorders, same bird probably, or two different birds, but there were just few sites that would be occupied highly and close to each other for American robin. One can think
Ondřej,
more
can you
about.
walk us through these graphs? What are the colors signifying?
Yeah, I was a bit too fast. Thanks.
All good.
Yeah, we can look at this Western tanager maybe. So the colors are the different SD. The green sides here are the sides that are similar. They either had a lot, both, or a little of recordings. So you see how it's growing, and it's basically linear, and the amount that we see on top or left, it's same. So for the Western tanager, we had many sites that had both a lot of recordings as well many sites that had both just few recordings next to each other in the same habitat. But then here with the Western tanager, maybe what's interesting, we have more of the purple ones, and those are the double sides when one side would have many recordings, yeah, and then a long way to the other side, which would have much smaller number of recorded intervals. So just showing how it could be diverse, and here it's so equal even with the Western tanager that we can, yeah, in the same habitat, we can once have many detections of Western tanager, go 500 meters away, and there will be no detections. Although the Western tanagers are there probably for sure, it's just the placement of the recorder or the way how we analyze the data and the limited detection range. Yeah, so in the Western tanager, it was very common that there were two birds and both highly occupied. And mountain chickadee, here maybe it comes to the fact that it's more specialist, so we see a lot of green, the most of all the species. So when there is a mountain chickadee, 800 meters apart, there will be another mountain chickadee for sure, probably because they select for the habitat. Okay, now the take-home message from the previous result chapter is, yeah, everything is possible, and what we record would vary a lot among the recorders. That's nothing new, but maybe good to remind ourselves. And another thing, that's we come more to the ecological question. For instance, I wanted to look at the dawn chorus behavior. The idea was that higher you go, more sun there is, the birds would start singing earlier. But to know it, or to answer this question, we need to pick up the first songs and be sure that we will pick up the first songs. And we don't know that. If I don't look, I don't check the recordings, I did not. But I will show you what I did. What are the limitations of this BirdNet approach / passive acoustics? The confidence interval that we will use, and we will select the sites, is influenced by amplitude mostly. And the amplitude itself is influenced by the distance of the bird, which would vary a lot. Yeah, the bird moves, that's probably what we saw with the American robins that sing from a long distance, and further they go, they can even disappear from the detection range, and then we would not pick up the first songs or any song. What's important is orientation of the bird. So if it comes behind the tree, then suddenly the confidence interval of BirdNet might drop, and we would put it to the, for instance, 85% subset, and it might be considered as false positive subset. Whether it's clear that if it's raining, then the sound would not be clear, and the BirdNet would not be sure in detecting the species. What's very important is type of call. For now, BirdNet does not distinguish between song and call, any call type. So if you get BirdNet detection, I cannot ask question like, what's the time of the first song? Because the first detection of BirdNet might be actually call, alarm call, or any contact or flight call. And lastly, time and position and chorus. If the area is many other birds around and there is some birds singing next to the microphone of other species, it will overshadow all other species in the background, although they are still close. And to see if the BirdNet can pick up the first songs, what I did, I checked the time difference between start of the recording and first detection for each side or each species. And we don't see it, but there is a gray line, and that's the start of a recording, and the red is the detection, the time of first detection. Here for one side for American robin. And we see that the BirdNet was very good. Once it started recording, it picked up the first song of the robin. So that's good. What's important to mention, this was side that had 54% of those 10 minutes intervals occupied. So it was very highly occupied side. The American robin was around, and the recorder was recording the American robin most of the time. But if we decrease that, go and look at the sites that have a bit lower proportion of those 10 minutes intervals occupied, we see that suddenly there is a slight variation. Here one day, BirdNet, I don't want to say failed, it's not a word, missed the start of the song or the first song. That could be the robin was not singing, was not there, or it was raining, so it might not be fault of these methods. But if you look in then sites that have lower proportion of the intervals, still pretty high, 20%, we see that picking up the first songs varies a lot, and we are probably missing something. The robin was a bit further, or was, as I showed before, was behind the microphone, or there were other species singing. So suddenly I cannot use this to answer the questions like, what's the first time of first song for American robin? Or if I want to use it, I need to use just sites that had most of the 10 minutes percent intervals most of the time with detection. Yeah, so here just a comparison, more percent of those 10 minutes intervals with detections, the difference between start of recording and picking up first song would decrease. It's a clear relation, and it's for all species. So we are not picking up all the songs of the species or of the individuals on site, and that might be just because the territory is too big, the detection range is small, or in fact using the BirdNet would decrease the detection range even more. So from 100 meters, for instance, we go to 50, because any song that's above 30 or further than 50 meters would not have sufficient amplitude to be of good quality for BirdNet.
Ondřej, could you walk through those figures again, just with the axes and the pattern?
Yeah. So this is the same criteria. That's the percent of all 10 minutes intervals. So if you split the 35 days in 10 minutes intervals, how many of them had detection? We see some sites at about 50% of them. And then I asked y-axis, what's the time difference between the start of recording and first detection that BirdNet had for that site? And we see that for sites that had many of these detections, the time to pick up the first song was generally smaller than for sites that had less of these detections.
Mm-hmm.
I hope it was clear. But if I said it in like other words, no. Yeah.
Sorry. So what do you interpret as that being that pattern there? That means like on the left-hand side of that graph, the territories, they're like the chickadees just aren't right around the recording unit. They're like on the fringes of the detection radius of the recording unit.
Exactly. Yeah. Maybe I should say like that. It's exactly this scenario. So what we saw was this probably, when the bird individual on the left side was just touching the detection range, whereas those that had high number of intervals in total and also were good at picking up the first songs were overlapping with the bird territories. And
Okay, yeah. Thanks.
Yeah, no, fine. And yeah, and now still we can look at some of the trends. I need to rush a bit, right? And So I will go just quickly. When we plot all of the detections in one graph compared to sunrise, when I wanted to look at the dawn and dusk chorus patterns for different species, if we can see some trends. This is Western tanager, and we can see indeed they have distinct dawn chorus. The recordings or the data that I have started later than their dawn chorus, so that's why there is overlapping with the start of recording. But for Echoon woodpecker, for instance, they started after the recording, and we see very clear pattern of start of the day, which I did not expect somehow from woodpeckers, that they would have such a consistent start of a day, their vocalization. With chickadees, we see that their dawn chorus developed rather in mid-May, and they stopped using the dawn chorus at the start of June compared to robin. Again, that's probably not shocking, because maybe they don't breed so long or so repeatedly as American robin and Western tanager. But still, we can make these graphs, and this is a dusk chorus. So the red black line is end of recording, and yellow is sunset time. And I think what's interesting is the mountain chickadee here, that they don't have any distinct dusk chorus compared to other species. Again, Echoon woodpecker has very straight line every time they would finish the last vocalization at the same time, which is very nice. What's maybe interesting here also is the Western tanager, this like drop for 1 week. I'm not sure, I did not have time to look at what was the cause. I guess maybe some temperature change. We can slightly see it also in a robin. So maybe there was this, it's a whole gradient, so it's not just locally, it's many sites. Yeah, and lastly, I will just run what we can see was the limitation. Here, these plots show where is the best time to go out and listen for Echoon woodpecker, basically where's the time intervals with highest numbers of detections. And we see it's the end of July and most of the day. And why it's so? I thought the Echoon woodpeckers would breed earlier, and I reckon it might be calls of the young ones. And so yeah, it's a bit confusing, because BirdNet does not distinguish those calls of young or families and song. So, but still, if we want to do bird census and go out for Echoon woodpeckers, the end of July would be best time. And for other species, again, we can look at this. I will finish with conclusion already, rather, right, Ben? We are running out of time.
Yeah, we can go a few minutes over. But yeah, I think your discussions will be a good part of the talk, so.
Okay. Then I will pick up. You see how it varies quickly. Just I mentioned the Echoon woodpecker, right? Vireo, that's maybe interesting. They don't have they sing the most or call the most during the day. There is no distinct chorus, or definitely it's not the most vocal time for them. But what I found interesting is the Western tanager, this evening activity at the start of the season in the middle of May. Similarly, American robin, maybe the dusk chorus is also important before like pre-breeding period. And lastly, I look at the relation between elevation and the time of the last detection. That was the only thing I could do. And yeah, we see there is a tendency that higher you go, the species would stop singing later, because there would be more light, I guess. But there were the limitations that I mentioned, that we don't detect all the songs. So the time of the last song is not very precise. There's a lot of variability in the data. And this I can skip. I then look at the elevation gradient, but that's not so interesting. So discussion and conclusions. I try to answer these two questions. And what I learned, what would be my take-home message? We should be very careful with how we use the outputs of BirdNet here or other machine learning, and we should maybe discuss a bit more what use, and it seems it's very species specific because of different life histories of the species and the way how they move around, how they vocalize around, and so on. The placement of recorders, even in the same habitat, we can record very different things, and that would affect the modeling or the outputs for modeling. So that's important to keep in mind. And we cannot move forward without having BirdNet updating. I think they work on it already, to distinguish songs and calls if you want to answer some ecological questions about dawn chorus or the dusk chorus behavior. And yeah, lastly, we are not picking up all the songs. If we place there just one recorder, we would need more recorders. Then I believe the BirdNet would be good, but there are still the limitations that I mentioned, that the detection range is decreasing due to the amplitude thresholds. And yeah, and that's it. And thank you for listening. I hope it was clear. Many things to share and many graphs. And I'm looking forward to discuss it with you.
Does anybody have any questions or maybe some experiences with having recorders out in similar areas and getting different species recorded, or I don't know, faced limitations in your own passive acoustic monitoring work?
I put a question in the chat. I'll just maybe we didn't see it. Yeah, this is really cool, really great visualizations. I was wondering, like in the Amazon, I think it's pretty well established that like eye size is a good proxy for onset of the dawn song, right? So bigger birds, which usually live in darker understory areas, will start calling later, right, than their counterparts. I think that's the pattern. I was just curious if you thought about like the ecological kind of attributes of these species and as predicting those kind of dawn song curves.
Yeah, for sure. I think we can find it there, or reflect that the thrushes would start earlier, bigger eye size. I did not look at it specifically, and why it was. That's my bit concerns about how well we actually know that it's the first time or the last time of the song. Sometimes if we miss if I would use also the sides with a bit lower at the edge of the territory, it was obvious that sometimes like 15 minutes drop, I would expect the time of the last song 15 minutes later, and I did not have it in data. And that's fine, but then in the estimates and with the number, I felt I don't have the correct data to go forward. I knew I'm missing it and it's not correct. Like the last song was actually later and I did not record it. So maybe you know some stats, or some of you that with a bit control for it, but I feel like do that, we are running in a risk to saying something which is not super correct. It's still correct probably in the trends, but yeah. Maybe I should not say correct, but like what's happening there. Yeah, and I saw a comment from Connor. Thanks. Yeah, I think it's coming. It seems who did not see it, that the BirdNet can distinguish other sounds or the call types, and that's very exciting. And I think that would accelerate it a lot of new research questions, and it will be cool.
So back to your original question, do you think that maybe given what you learned over the summer, if you had more time, or what other data would you need in order to answer your question about mated males versus unmated males?
Yeah, that's a good one. I think I would need to. I would decide to place more recorders there, rather more than less, and then you go. But then it's losing the low cost of placing recorders randomly in the territories, and suddenly it's like a species specific study. And for that, I think we can use it. It will be great. But if I want to know this or distinguish, I would place more recorders to be sure I'm picking up all the songs and I'm not missing anything. Still, I can use the BirdNet. I think it's super good. We saw when the species is around, it can pick up most of the songs. But we need to place it in a territory or have more recorders so they pick up most of them. Yeah. No, so I'm positive then. After all, I hope it was positive.
So I guess one big takeaway is like for people that are working with PAM data and they see that some species with a limited number of detections, that might not mean that those birds are rare in these areas. It might just mean that they have territories on the outer edge of wherever this recording distance is. And so maybe caution with your interpretations given this context. Would you say that?
Absolutely.
Okay.
Yeah. And second, or I found it maybe more important is the slide you see, and that's how our decisions about what subset of data we use and for what species, how like dramatically influenced estimates of nave occupancy. We are not talking even about modeling than occupancy itself, which would be even more affected by then. This is just what we have. That I found like, yeah, we should more think about it, maybe discuss it.
Hey, Ondřej, good to see you again. Nice work.
Nice.
I think it seemed to me like one of this big challenge that you were trying to address was all of these unmeasurable spatial processes that are affecting your data. And so you didn't have access to any spatial information about the birds, and you're trying to infer these spatial patterns from essentially temporal patterns. But you were looking at a really, really fine temporal resolution, like a 3-second you were zooming into the calls, which are reported on a 3-second basis, and then even these 10-minute intervals. Do you think if like zooming out in time could reduce some of this weird variation that you're observing? So instead of considering things at a 10-minute interval, looking at a week-long time interval, that some of the weird variation, complex variation would go away, and that would make things a lot simpler.
Then yeah, that's a good point. Then I think it depends on the question. But still, yeah, we are not recording everything what's happening. So if I want to ask when is the best time to listen for first songs of mountain chickadees, I can scale it up in a way, maybe, or for first hour, but still that's very imprecise or far from, because yeah, some of the sites would not pick it up. So I would be I'm a bit, you know me, I'm a bit cautious maybe to scale it up, because I have a feeling that we don't have everything what's happening there for some species. But I can imagine for some questions it's possible. Absolutely. And the species presence absence only, it works well. Yeah.
We've got a few more questions in the chat.
Okay, thanks. I'm reading about the warblers, and how do you incorporate the population of the species to get a better insight? Yeah, I'm not sure I understand it well. please maybe can describe it more. But if I understand it well, I would.
Yes, Ondřej, in my master's, I had studied the temporal partitioning of warblers, and in that I got the data like one species was vocalizing more actively in the morning, but that might be influenced by more number of individuals in that area. So how to negate the population of a species and its activity so that we can bring both the species on the same level?
Yeah, well, again, it's like it seems like this is again more than a species specific study, when it would be about placing more recorders and ideally knowing the individuals, which is we heard it's a bit possible with the density estimations in the talk, I think 2 weeks ago, and so maybe go with that. But it's another limitation. I did not include it. It's a good point that one singing individual might be influenced by another or losing mate during a time, and we don't have this data, of course, unless we go to the field. If I answer it.
Yeah, thank you.
Yeah, for the spatial occupancy, I played a bit with these spatial models, and I got similar results. I felt like the spatial occupancy is based on the habitat coverage we put there, or not any occupancy. And but from what I've seen in data, for the same habitat, we can get very different results. The species, I believe the species are there, but they were a bit further, or we did not get so many detections. So if it can help, it would even increase the naive occupant or the occupancy estimates. And then it's again about the question what kind of the subset of data we use, and which sites we would consider as occupied and which not as occupied, even if the species was detected there. If that's it. Yeah, admin is asking. I did not decide to use these devices. I was the guy behind the computer, and I did not go to the field, so I'm not sure what was the decision, but this is long time running project. So yeah, because they were not there at the time. Yeah, exactly. Yeah. Thanks for the questions. It's great.
Well, thank you, Ondřej. You covered a lot in this presentation and raised some interesting issues and ideas. So we'll meet again in 2 weeks. I think we've got a presentation about a new package in, I believe, R or Python, about it's a sort of easy way to apply convolutional neural nets for bioacoustic analysis based off a recent methods paper. So should be a good one. And we'll see you all soon. Thanks again, Ondřej.
Yeah, thanks for inviting me. It was great. Thanks.
Ben,
See you later, everyone.
That one in 2 weeks.
His name is Bruno. Larissa is helping to organize that one. Let me look it up. I think Bruno Silva.
Oh, okay, yeah. I think I know what paper you're talking
So
about.
it's Sound Class, which is a new package, and it came out in a paper in Methods in Ecology and Evolution. And so Bruno will be walking us through this method in the coming session in 2 weeks.
Yeah, that's an R package,
Okay, nice.
but I think yeah. I saw that paper. I just still am hesitant to use like, I think it's good that R is, there are more resources being implemented for R, but I still, like, when I looked at that model, the number of parameters is like vastly lower than what like a ResNet or something would have in Python. So I think it's still kind of limited, unfortunately.
Well, maybe for the R lingual people, the ones that, you know, are anybody who's only comfortable working in R, it's another possible tool.
Oh, I still love R more. I begrudgingly Python for machine learning.
Yeah, I'm with you on that. I'm also sort of R slanted. But in any event, we'll see what Bruno's working on, and you know, it could lead somewhere more comprehensive, or maybe it is already.
No, you gotta have something to build off of.
Yeah, exactly.
All right, cool. Thanks,
We'll
Ben.
see you in 2 weeks.
Yep.
All right, bye.